Identifying quadratic functions. How can I identify a quadratic function from its equation form, table, graph, and context? We'll start with the standard form of a quadratic function. So this is the equation form. A quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c, where a is not equal to 0. So that tells us that there must be an x squared term for it to be a quadratic function. We call the x squared term a quadratic term. It usually has a linear term and a constant term as well. In this function, f of x equals 3x squared plus 4x plus 1. We call 3x squared the quadratic term, 4x is the linear term, and 1 is the constant term. So now we're going to take a look here and determine if these three examples, if they're representing quadratic functions or not. So in example A, we could rewrite this in standard form by subtracting a 7x from both sides. It would be y equals 4x squared minus 7x minus 6. This is indeed a quadratic function because it has the x squared term. The next one, when we write it in standard form, we would put the x term first and then the constant. This is not a quadratic function. In fact, this is a linear function. It's the graph of a straight line. In the next example, if we solve for y, we see that we have a couple of x to the third terms which can be combined. This is not a quadratic function. This is actually a cubic function because it's x to the third power. So that's how we can identify quadratic functions in algebraic form if the highest power of x is x to the second. Now let's take a look and see how do we identify quadratic functions from their graphs. We have a table of values and we have this function, y equals x squared. I just substituted negative 4 in place of x. Negative 4 quantity squared is positive 16. Negative 2 squared is 4. 0 squared is 0. 2 squared is 4. 4 squared is 16. So I'm going to plot these points. And I can see that we have this type of U-shaped curve. This is the graph of a quadratic function. It will look like this. Part of the curve is going to be decreasing, and then at the vertex, or at the minimum value in this case, the graph changes direction. Here, let's graph something with a negative number multiplying the quadratic term. So the y value at x equals negative 2 is negative 3 times negative 2 squared. Well, I'm going to square negative 2, I get 4. 4 times negative 3 is negative 12. The y value at x equals 1, negative 1. I want to square negative 1 and I get 1. 1 times negative 3 is negative 3. I'm going to square 0 and get 0. 0 times negative 3 is 0. Squaring 1, I get 1. 1 times negative 3 is negative 3. And the value of the curve at x equals 2 is negative 12. So I'm going to plot these points. And I'll connect them with our curve. And what I notice about this particular curve, it is also a U-shape, but this one points down. It has a quadratic term, and the graph is called a parabola. That's the name of this type of curve. Now, if I take a look at my table of values, I notice as x increases by 1, here y is increasing by 9, but then y increases by 3, then it decreases by 3, and then it decreases by 9. So I know for sure this, if all I had was the table of values, this would not be a linear function because there is not a constant rate of change. But if I now look at the second difference, here I'm decreasing by 6, and again I'm decreasing by 6 and decreasing by 6. Turns out you will be able to recognize a quadratic function from a table because the second difference is constant. Now what about the direction of a parabola? At what point, when does the parabola point up or down? So what we want to notice is in this first function, we have a parabola for sure, because it's got x to the second power. The number that's multiplying the x squared is positive. If I were to graph this function, it would open up. In the second example, I want to rewrite this in standard form so the x squared term comes first. Notice the x squared term is being multiplied by a -1, so this one will open down. And so we want to pay attention that in the standard form of a quadratic function, if the x squared term or the quadratic term is positive, the parabola opens up. If the quadratic term is negative, it will open down. So we looked a lot at the equations of the parabola or of the quadratic function in this video. We talked about the table. We talked about the graph. Now we want to think about the context. What would a typical context of a quadratic function be like? Here we have that a pebble is dropped from a 256-foot tall cliff. And the equation 256 minus h equals 16t squared can be used to find the height h of the pebble after falling for t seconds. So gravity is affecting this. And it says find the height of the pebble after falling for 2 seconds. So here we just take the equation that was given, and we can write this in standard form by getting the h all by itself and getting the h positive. So h equals -16t squared plus 256. We want to find the height of the pebble at time equals 2 seconds. So we substitute 2 in place of t. And we just multiply this out. -16 times 4 is -64, plus 256 is 192. So the height of the pebble after falling for 2 seconds is 192 feet.